Hello. Hello, good morning everyone. It's good to be here. I hope you all enjoyed EDCon as I have throughout. Today we have a bit of a hybrid format because Kigen wrote the research paper of the improvements on the privacy pools. So please bear with us when we make the swap. But I'll be presenting on improving privacy pools and blockchain governance with agentic-enabled cryptography. So just a quick brief on what GBIN is. The Blockchain Governance Initiative Network. We're a sort of global think tank standard-setting body coming out of Japan and supported by the JFSA. We host meetings twice a year to discuss blockchain governance. So everything from identity key access management, of which I'm the co-chair of the working group for identity key access management, as well as financial and social economy applications of blockchain. And there's a few things that we discuss in the forum. We receive regulators, we have industry practitioners, cypherpunks, cryptographers. It's a really good sort of mixed group. So we're able to get into the details of what's going on. And our work item for the past almost 2 years has been observing the privacy pools paper and then trying to make improvements using the experts in the room. Sort of improving the protocol, and in other words, creating associations that providers through governance organizations. More recently, I've written an agentic framework for GBIN, so to build an agentic workforce alongside the governance activities and the forum that we create. So there is actually a convergence between governance, AI, and privacy pools, aka the cryptography which protects your privacy on chain. So without further ado, throughout the time as a chair of the GBIN organization, I've noticed a lot of difficulties in governance. One in particular that I find struggling is temporal blindness. So temporal blindness is this issue where people, when they have focus and energy on a particular subject, they provide a lot of value in that moment. However, over time, there's decay and it's diminished because people are busy. They have other things that they want to do. They have other activities. They run businesses. So being able to capture that essence when it happens and then use it to train an agentic workflow, that's what we're trying to do now at GBIN. So then we don't have this issue of sort of blindness over time. This also leads to the knowledge fragmentation issue, similar issue, where a lot of governance insights are actually siloed amongst lots of groups. I think this is particularly a problem in blockchain because we have lots of chains that all have their own governance that all look very similar, and there's a little bit of crossover between the two. And a lot of them have the same problems, don't really talk to each other all that much unless there's a person that sort of is that bumblebee that navigates between the different blockchain networks. Scaling is always an issue. Ethereum loves talking about scaling issues. Scaling is also an issue in governance. And of course, there's privacy trade-offs as well. One issue that we've discussed a lot at the GBIN organization is around sort of on-chain transaction monitoring compliance. And when we get organizations like Elliptic, Chainalysis, and these sort of transaction monitoring firms that create nifty heuristics for demixing funds, it's their competitive advantage for them not to tell us how to do that. However, when we look at fighting crime and trying to solve the AML-CTF issue around the world, information sharing is critical. So I actually see those two things at odds. So what we've developed at GBIN is what I call an agentic Chatham House framework, where people are able to provide contributions, but the attribution is not listed to them or their organization. And then using sort of AI as the privacy vehicle here, we could potentially get more information sharing. So we've designed 3 different agentic workflows to make this all happen. An archive agent is the institutional memory of any given subject or organization. So see it as the RAG, where people are able to contribute information and intellect and their sort of access to this knowledge store. A codex agent converts a lot of this information into code. So you could imagine a standard, like an ISO standard, what we're able to do is use that ISO standard and support organizations in converting their policy and adopting that standard. And then finally, the discourse agent. It's a sort of a median for the human interaction with the agentic workforce. We use discourse, which is a forum space. So it kind of has a double meaning here. Discourse is also, of course, dialogue. And what we're able to do is have the prompt inputs through discourse and have this ready forum that constantly goes through. And then the agent actually acts as this, as I mentioned before, this Chatham House median, where the discourse agent posts the insights and the information, but doesn't attribute it to those who provided the insight originally, unless they would like to, and that's where the privacy pools comes in. So let's just jump straight into privacy pools. I know it was a little bit of a divergence on the agentic framework here from the topic. However, I'll tie it all together in the end because, and I'll just leave this with you to think about. Like, what is value? Well, value in the blockchain space is represented as data. So value to AI agents is information and data. Value to humans is tokens and what we prescribe value to. So let's think about Tornado Cash, just briefing on the privacy pools concept, and then we'll get Kigen, who's online, to share how he has improved on the framework and the protocol. Tornado Cash, many of us know, it is a privacy solution where you're able to deposit a certain number of coins, so typically 100 Ethereum, and then make a withdrawal, which is unlinkable. Now, there was like a lot of controversy and issues around this in the industry as it was OFAC sanctioned, and that's recently been lifted, but it does sort of raise some concerns. So one of the iterations on the Tornado Cash was this privacy pools concept, where we were able to build association sets. And now imagine, how do we build an association set provider? And that's where GBIN is looking to take a role. So we're enhancing the privacy pools. One critical vulnerability that we identified is that it is very easy at the moment to build a malicious association set provider because there aren't really very many association set providers. OXPO is one of the only examples in the market, and they have a fair amount of liquidity in the system, and we do trust them, but how are we going to trust a burgeoning association set provider ecosystem? This is where sort of GBIN could play a role in building different types of association sets for different use cases. We did some research called the Accountable Wallet Framework, and this uses on-chain attestations for compliance. So imagine checking if you're on a sanctioned list, you then receive a proof saying that I'm not on a sanctions list, and that informs the association set. So when you go into a privacy pool, you can transact with other people who you can be assured through the cryptography that they're also not on a sanctions list. Now this builds sort of almost like a fragmented liquidity ecosystem, which will have its ramifications in of itself. However, it does get us closer to this real world asset realization on chain, where you do have these checks and balances that exist in the traditional finance space, such as KYC. Not as much of a fan of KYC, but I suggest that with association sets, we'll be able to build different sort of credentials, which are a little bit more closer to the human and a little bit less reliant on bureaucratic identity and more reliant on other things. So this is where the original accountable wallet idea comes in. And we proposed it at the financial cryptography workshop. So the core idea was wallets undergo KYC or some sort of proof. You then have this generation of proofs over time, where one wallet has a credential, which then layers into another wallet, which has a credential, to build this sort of layered approach. Now, this is highly complex, and that was some of the feedback after we published the Accountable Wallet paper to Financial Cryptography Conference, FC. It was a little bit difficult to envisage this being a real use case because of the complexity behind having multiple proofs behind multiple wallets. Adoption would be difficult. So this is actually where Kigen steps in, and over the last year or so, he's done some more research in simplifying the Accountable Wallet framework and improving the privacy pools association set creation. So if we would be able to, Kigen, jump in if you are there.
Can you hear me?
Yeah, we can hear you.
Sounds good. Yeah, thank you for introduction. I'm Kigen Fukuda, and okay, let's see. I think we are kind of running out of time, so let's quickly see like how we can simplify the accountable wallet idea. Uh, and so we can simplify this, the complicated proofs into two proofs for first. So the proof of the wallet owner being unsanctioned and the proof of the legitimacy of the coin provenance. So when the Alice transact with Bob, I'm sorry, that's you're going. Okay. And the Alice provenance proof consists of upstream sender Carol, her unsanctioned proof, and the provenance proof. And this recursive structure continues to the end of the transaction history. And the end will be the exchange deposit or Coinbase transaction. And we want Bob evaluate Alice's legitimacy by just verifying the proof sent by Alice. So to further simplify this is recursive structure, let's compress the transaction history as the accumulated compliance score, simple Scala value. Then Bob just needs to verify Alice's compliance score and the unsanctioned proof. Next. So however, there's still a scalability challenge. So the accumulation of all proof leads to exponential growth in proof size and the verification time. And delegating to centralized authority, this costly calculation also enables censorship, perpetuating the problem we are trying to solve. So the solution we propose involves these three components. First, the verification data records. Second, the chain of trust. And third, the watcher network. And let's take a closer look how these components work together. So before transaction, the sender presents like locally calculated wallet compliance score and non-membership proof of the crypto watch list. Recipients then decide whether to proceed to the transaction based on the verification result of the score and the proof. The important thing is here, the recipient only checks the immediate sender's score calculation and non-membership proof, trusting upstream sender's score. So the red rectangle here shows the recipient side. The malicious attacker can forge the score and deceive the recipient easily by having a multiple self-custody wallet. A sanctioned coin owner may send a coin to the other newly made wallet and claim the recipient wallet conduct necessary verification and also forge a fraudulent score between them. So if this happens out of the owner's recipient side, then recipient has no way to notice this fraud. To prevent the attacker successfully compromise the integrity of the score on this trust chain, we have verification data record, VDR in short, and watcher. The sender leaves the VDR, which includes the compliance score, non-membership proof, and the recipient's signature to show the consent of receiving the fund. Also, this VDR enables watcher to detect the faults efficiently by re-verifying it. Also, watcher can identify the fraudulent transaction. More importantly, the recipient can use VDR to prove their good faith of accepting the funds. So we're delegating the fraud detection to the watcher. Is the screen fine? May I keep?
Just a moment, sorry.
Yeah.
Yeah, we're back.
Okay. So I can't see the screen, but yeah, I think you can switch it properly.
Yeah.
So we're delegating this fraud detection to the watcher, and we can think of two models for watcher verification. So the first model is what we call decentralized compliance scoring, and the second model is called optimistic verification. So the next slide. So let's see the first model. So decentralized compliance scoring. So as already explained, the sender calculates its compliance score and show it to the recipient with the non-membership proof. The record of this negotiation is stored as VDR. And so what the watcher network do is detect the fault in sender score calculation or recipient's non-membership proof verification through periodic VDR verification. Also, they identified a fraudulent transaction and add bad actors detected to crypto watch list. Also, they correct the affected score through attestation issuance. Also, they operate with the mutual monitoring and economic incentive of slashing deposit to penalize the malicious watcher in the network. So the watcher may be like companies like chain analytic companies, like, chain analysis, elliptic, TRM, and so on, or even include the regulatory body itself. They also may be incentivized by getting paid from seeds property when they detect the fraud. Also, the watcher network guarantees the score integrity to ASP. So let's go to the second model. So we call this second model as optimistic verification because it looks like optimistic rollup. So in this model, user make assertion of the compliance score when they try to make a deposit. So then the deposit request is pended for 7 days, and watcher will submit the fault proof pointing out the fraudulent transaction or fraudulent wallet, claiming the wrong compliance score in the transaction history. So we can call this watcher as a challenger in this model, like following the optimistic rollup terminology. So if no fault proof submitted within 7 days, the deposit request go through the ASP and add it to the transaction, add it to the association set. The important thing is the fault proofs will be verified by EVM smart contract, so it relies on L1 consensus to resolve the dispute game. So therefore, the verification data record need to be stored in the smart contract readable manner. Also, there needs to be the compliance score correction mechanism triggered after the fraud gets proven. So the next slide. So one of the possible format to store the VDR is like using a schema like ERC7812 called ZK Identity Registry. It provides the standardized on-chain database entry point, access control, and the isolated namespace. So it is supporting the sparse market tree structure, which is compatible with non-membership proof. So therefore, we may store the VDR as a sparse market tree in the recipient's namespace. And ERC7812 is originally designed to store the commitments of the private data to later prove its validity via Zenora's proof. Therefore, this schema will be also useful for the original accountable wallet idea to connect the off-chain attribute information as verifiable credential and on-chain executable ASP verification of the deposit inclusion. Okay, that's my part.
Thank you, Kigen. So what we find with using or progressing towards enhancing the privacy pools concept is that we can do some compliance scoring around deposit verification. Association sets are an emerging thing, so management around that, we suggest it should be a government or non-government organization, think tank organization. Zero knowledge proofs are also essential here. And then, of course, there'll be withdrawal verification and fund tracking after which the adoption of sort of Kigen's research. So the roadmap for getting this all to happen, we're actually leading towards Block 13 in Washington, DC in mid-October. And Block 13 is where we're going to experiment with some of these concepts using that sort of agentic workforce that I was mentioning, so training agents on being the verification systems and the credential systems as well. So we'd like for the Ethereum community to be involved in that process as much as possible. So the convergence, what is value? So data is value to AI, tokens are value to humans, and if we're able to build these sort of value privacy pool systems on chain, I suggest that we could actually have privacy pools for decentralized governance as well. So if you could imagine making inputs in sort of governance activities and that going through a privacy pool concept too. So the beginning of constellations. We can have institutional wisdom, privacy, and accountability, as well as quality at scale, using the privacy pool concepts for both money as value, on-chain value, but also intelligence as value. Thank you so much.
'Thank you very much. ありがとうございました。